Today, people know that Earth is a sphere located in space and moving around the Sun, but it took hundreds of years to develop this scientific model of Earth. Around 600 BC, one early Greek scientist, Thales of Miletus, hypothesized that Earth is a disk floating in a pool of water. Another Greek scientist, Anaximander, suggested that Earth is a cylinder floating in space. He thought that people lived on the flat top of the cylinder. Around 350 BC, the Greek scientist Aristotle used evidence from everyday observations to support the idea that Earth is a sphere. For example, Aristotle pointed out that a ship sailing away from shore appears to sink beneath the horizon because Earth's surface is curved. If the Earth were flat, the ship would simply appear smaller as it moved away. After Aristotle, other Greek scientists used the knowledge that Earth is a sphere to help them measure the size of the Earth. Eratosthenes, a Greek scientist who lived in Egypt more than 2,200 years ago, calculated Earth's size. Using measurements and principles of geometry and astronomy, he arrived at a figure that was accurate to within 14%. Maps and globes show the shape, size, and position of Earth's surface features. A map is a flat model of all or part of Earth's surface as seen from above, and a globe is a sphere that represents Earth's entire surface. A globe correctly shows the relative size, shape, and position of land masses and bodies of water, much as if you were viewing Earth from space. What are the similarities and differences of maps and globes? Pause the video and create a Venn diagram in your interactive notebooks, comparing and contrasting maps and globes. Maps and globes are drawn to scale and use symbols to represent topography and other features on Earth's surface. As you can see, a map scale relates distance on a map to a distance on Earth's surface. Scale is often given as a ratio. For example, 1 unit on a map could equal 150 units on the ground. So the ratio would be 1 to 150. In your interactive notebooks, ask yourself the question, what is the purpose of a scale? If you were a map maker, you would use shapes and pictures called symbols to stand for features on Earth's surface. A symbol can represent a physical feature such as a river, lake, mountain, or plain, or it can stand for a human-made feature like a highway, city, airport, or campground. A map's key or legend is a list of all the symbols used on the map with an explanation of their meaning. You can see why this is very important. A map maker would also need to include a compass rose or north arrow. The compass rose helps relate directions on the map to directions on Earth's surface. North usually is located at the top of the map. Let's talk about an Earth reference system. When you play checkers, the grid of squares helps you to keep track of where each piece should be. To find a point on Earth's surface, you need a reference system like the grid of squares on a checkerboard. Of course, Earth itself doesn't have grid lines, but most maps and globes do show a grid. Because Earth is a sphere, the grid curves to cover the entire planet. Two of these lines that make up the grid, the equator and the prime meridian, are the baselines for measuring distances on Earth's surface. To locate positions on Earth's surface, scientists use units called degrees. You probably know that degrees are used to measure the distance around a circle. Degrees can also be used to measure distances on the surface of a sphere, just like the Earth. Each degree is a measure of an angle formed by lines drawn from the center of Earth to points on the surface. Halfway between the north and south poles, the equator forms an imaginary line that circles the Earth. The equator divides Earth into the northern and southern hemispheres. A hemisphere is one half of the sphere that makes up Earth's surface. Another imaginary line, called the prime meridian, makes a half circle from the North Pole to the South Pole. The prime meridian passes through Greenwich, England. Places east of the prime meridian are in the eastern hemisphere, while places west of the prime meridian are in the western hemisphere. Using the equator and prime meridian, map makers have constructed a grid made up of lines of latitude and longitude. The lines of latitude and longitude form a grid that can be used to find locations anywhere on Earth. The equator is the starting line for measuring latitude, or distance in degrees north or south of the equator. The latitude of the equator is 0, between the equator and each pole are 90 evenly spaced parallel lines called lines of latitude. Each degree of latitude is equal to about 111 kilometers. The distance in degrees east or west of the prime meridian is called longitude. There are 360 lines of longitude that run from the north to the south, meeting at the poles. Each line represents 1 degree of longitude. A degree of longitude equals about 111 kilometers at the equator. But at the poles, where the lines of longitude come together, the distance decreases to 0. The location of any point on Earth's surface can be expressed in terms of the latitude and longitude lines that intersect at that point. For example, you can see that New Orleans is located where the line for 30 degrees north latitude crosses the line for 90 degrees west longitude. To show Earth's curved surface on a flat map, map makers use map projections. There are 3 different map projections that we will learn in 7th grade. The first is the Mercator projection. Here, all the lines of latitude and longitude appear as straight parallel lines that form a rectangle. The size and shape of landmasses near the equator are only distorted a little bit. To solve the problem of distortion on Mercator projections, mapmakers developed equal area projections. An equal area projection correctly shows the relative sizes of Earth's landmasses, but an equal area projection also has some distortion. The shapes of landmasses near the edges of the map appear stretched out and curved. If you place a clear plastic cone over a globe, trace the lines of latitude and longitude, and then unwrap the cone, the result would be a conic projection. In a conic projection, lines of longitude appear as straight lines while the lines of latitude are curved. There is little distortion on these maps, but it's used mostly to show limited parts of Earth's surface. Okay, let's jump to 2013. Let's talk about maps and computers. Most of the data used in computer mapping is gathered by satellites in space. However, today, most map makers can collect data from maps using a GPS. Alright, that's just about all you need to know about maps. Take a minute to answer these 4 questions on the left-hand side of your interactive notebook.